So now we're going to talk about the actual template language. As I mentioned before, there's more than one templating language. We're using the default one. And I think it's actually one of the better ones, this whole notion of double curly braces. There's all kind of templating engines, and a lot of them use these double curly braces. Sometimes there's a one called mustache because the curly braces look like a mustache. So this double curly braces, you learn it in Django and you'll find it all kinds of other places. I've used it in front-end processing. This is back-end processing because we're doing all the substitution in the back-end. So there's basically a couple things you can do. The double curly braces do substitution, and one thing that's cool about this, if you recall, I talked about how you have to escape data that came from the user. Anything in the double curly braces is automatically escaped. As a matter of fact, you have to do something to not escape it, because it turns out that 98% of the time you want to escape data that you're printing out, because it doesn't change what it looks like, but it does make sure that it's safe. If you add this vertical bar safe afterwards, that's like a modifier. I think it's called a filter in Django that says, look, don't run that filter on it to do the HTML entities. Just do it as is. I know there may be HTML in that, but I've taken care of that because I am the application developer. You can call functions, like with the code is the percent, curly brace percent. And there you tend to call a code. This is like code. This is like calling a method or a utility code. And so the first part of this is what you're calling, and then later you can have some parameters. So this URL says, I want to find a URL for the view cat detail, and I'm going to take the number that is the current cat primary key for the cat record and put that on as the URL as well. The author in this case is and we'll see this later, is a model item, and get absolute URL is a method inside that model item. You can have sort of ifs and if then else's. It's kind of Python-like, which is nice in that you don't really have to learn new things. There is looping code that's in there, like a for loop that we'll talk about in a bit. And then there is blocks that can be replaced. So you can have a template that sort of pulls in another template and then substitutes in part of it. So you can have whole blocks of substitution, not just little strings of substitution. And so we'll talk about each of these in turn. So here we go. We'll start with a real simple one. And you'll notice that in this particular simple one, we have no parameters on the command on the URL. So we don't have any parameters here. I'm going back to a non-class style, just a simple function, and I'm not sending a context. The context would be the third parameter on the render call, and so I'm just saying, hey, and this is what you do when you just have some static HTML that you don't really need to change anything, and so that's what's sitting in here. It's just a simple page. There's this thing called a built-in template view class that sort of does exactly this thing, that just grabs a template, turns it in grabs a file, turns it into an HTTP response, and sends it back to Django. So that's just a super simple template. Now here's one where we're going to take a parameter to the context, and I'm not taking it from the command line quite yet. I'm just going to make the parameter always be 42, and the key is, this is a key and this is a value. So zap in this case is the key and 42 is the value. I often call this variable context, but the fact that's just a mnemonic memory thing for me, context or CTX is what I tend to call it. And now I'm passing in the template, this template here, the guest.html template, and it has one little curly brace substitution, and remember that does escaping for us automatically, so there's no need to use escape the way there was when we were doing this via concatenation. That alone is a good reason to use templates. And so this ends up sending out your guess is 42. So this is just really focusing on what's in that context and how the things come out of the context. This name here, zap, in the context means pull the thing out of the context under the string name zap, and then it substitutes the results, like the 42. So instead of it saying guess was zap, it's your guess is 42. So that's really focusing on the substitution. So this is showing us how we do the safe stuff in case you actually want to pass some HTML into a template and actually want it to render as HTML, not as HTML entities or HTML entity style. So we're sending in a thing that's bold with a B and a less than B. That's HTML. It's got less thans and greater thans in it. And then we got zap. And so you can see that the zap comes out as 42. It's HTML entities, but it has no special characters. But if we escape text, text is the one with the HTML entity characters, that automatically escapes it so that you see the less thans and greater thans in the browser output. Escaped, less than B, bold, greater than B, right? And if you say text and then add the safe filter to the end of it, that says don't escape it. And so then this bold goes right into the HTML document, and instead of you seeing the less thans and greater thans, you're actually seeing the text turn to bold. Now, usually the bad folks that are trying to get into your computer are not just turning your text to bold, they're trying to run JavaScript. And all we're showing here is that whatever less thans and greater thans would be in that context value txt, they're going to end up literally in the document, and the browser is going to interpret them as HTML. I mean, there's just no way that somehow your browser knows the HTML that came from your program versus the HTML that came from a context variable, because by the time it gets to the browser, it's all one thing. And so it doesn't know, oh wow, that's dangerous, that came from a variable. No, by the time the response goes back to the browser, it's just a blob of text. Now we can talk about some loops here. I am passing in 2 arrays, apple, orange, banana, and lychee. And then I'm passing another array called n with peanut and cashew. And then I'm going to create a context. And in that context, I'm going to have fruits point at the list F, nuts point at the list N, and then zap is just the string 42. And do I even use zap in this one? No, I think there's another place that it. No, oh yeah, it's. I just don't have it in the. So here's the template, a part of the template. It's not looking at zap. And so here's the key. So we got this for loop. For x in fruits. Well, fruits is looking up something in the context under the key fruits. They're string. They don't look like strings in. They don't look like strings in the template, but it looks up there and it finds a list. So that little list F is what really is going on here, and F is a list of apple, orange, banana, lychee. And then X becomes the iteration variable. That's only within the template. And then I'm going to print it out, and then I'm going to end it. So that's like the start and end of a for loop. Apple, orange, banana, lychee. Now you'll notice that I have an li tag, which is the list item tag, and it just generates all that HTML. And again, the double curly braces are doing HTML entity escaping automatically. So, so we take a look at nuts. So we ask, is nuts present? Because that's a way to tell if variable's present or absent. If it's absent, I'm going to ask another filter on the end saying how long was it? Okay, and so this is the n, nuts is the n list, and it has a length of 2, which means it has 2 elements in it, and so we see the number 2. And so you can do various things. So this is an if then else, the syntax of an if then else, with curly brace percent. Now we can pass objects within objects, and so it's a little tricky. We have a context in this x variable, and the sort of the outer key is pointing. The key is outer is pointing to another dictionary, and in that dictionary there is a key of inner with a value of 42. And then we render the nested.html, and you see the outer, but then outer.inner, that's, so outer is that object, and then object.inner, then this thing becomes 42. Okay, so you can kind of walk through objects if you have hierarchical objects that contain objects, or lists that contain objects, or any number of hierarchical structure of lists and objects, you can walk through them. So here's just another simple example. This one has data coming in instead of hard-coded. So we again have game 200, and we're running into game view. It's a class view, and The 200 comes in as the parameter because we said it's the parameter that comes after the word game. And so guess comes in as 200. It's a string at this point. It hasn't been converted to an integer. So when Django pulls these off, well, it does some validation based on the types, but it doesn't actually necessarily convert them. And so we're going to create a context, x equals a key of guess, and convert it to an integer to pass it in. And then we're going to pass the context in and the template in. And so the word guess is going to come out. And we sort of saw this. The guess is 200. And then depending on the if then else logic, it's going to say, in this case, too high because your guess was 200. And of course the right answer is always. So now we're going to talk about a technique called template inheritance. And this and other times, it's a great time to review object-oriented programming because I'm just going to use object-oriented programming definitions and words and not completely explain them. So you got to know what a class is, you know what self is, those kinds of things. And I've got a great online lesson that you can go read and listen to and understand objects. And I'll explain it to you in 30 or 40 minutes. So inheritance, actually from that lecture, is the notion in object-oriented programming to not repeat yourself. You have some kind of a shape, and then you make a bunch of objects that mirror that shape. But you can also, with inheritance, you can have a shape that makes another shape, like a shape in general that's a triangle. And so you can inherit that all triangles have everything shapes have, and all squares have everything shapes have, and all circles. And it's just a way of capturing information once, writing code once, and then not repeating yourself. Functions are a form of DRY, don't repeat yourself. Modules are, but inheritance is the key. And inheritance kind of can get in our way as programmers because it leads to smaller and smaller code. If we're going to make 5 things, each of these 5 things is really small because we make a big thing over here and we inherit all 5 of those things from it. But then you look at it and like, oh, I don't understand that, right? I don't understand these only one-line functions. What are they doing? Well, the answer is there's 50 lines out here that we're inheriting from. So we'll see some of that. I'll try to kind of allude to that part where, look, there's magic over there. And a lot of what you do in Django is use classes and objects that you didn't even create, meaning that they've got data in them like .scheme or request.scheme. And so this is just also a way of trying to simplify the way you handle sort of things, objects that are handed to you, and then you hand objects to other parts of Django. So template rendering basically says, okay, here's some rendered data and here's a template. What happens now is there's this thing called a base template, and the base template and the template combine together to be sort of like the ultimate template, and then you pass in the rendered data and produce the rendered output. So let's just say that we had a bunch of pages and we were doing the same thing over and over again. Now we will soon do this with navigation because you want to put a menu at the top of every page, and literally that menu could be 40 or 50 lines of HTML, and you do not want to repeat that menu every time at the top of the page. So you want to put that one place, and then you want to make many pages that have the same top navigation so that your pages, as you go between them, look like the navigation is the same. So we're going to do this in a very, very simple way. So we have one template, this cond.html that we've been playing with. You'll notice it has some HTML and a title and a body tag and some of this, and then it's got this stuff. Well, let's say we wanted a bunch of pages that had that everything but the body. So what we basically then do is we take parts of this, like the repeated parts, and we put it into a template. And then we take the part that we're going to change every time and we put it into a template that then extends. So see, this one here has one line that says extends temple-base.html. So this one uses everything in here but then adds some stuff. Okay, so the basic idea is we split this one big template into reusable parts and non-reusable parts. And then we have a bunch of templates that come off a base. We call it base commonly in object-oriented world because it's like the thing that we're basing it on. So, you know, this is the base, and then we're going to build on it. Base, build something else on top of it. So how this works in practice, we have a view here. We're going to call this view game2, right? So we're going to use the URL game2. We have a class-based view. We have a get method in there. The request data comes in as request. We told it to parse the slug off the end and pass it to us in the variable guess. We make a template, which is exactly what we did before, where we have a key of guess and the value is the actual guess itself. And then we pass that template in the variable x into render, and we tell it to go read templecon2, which is the condition, the second conditional one. And the thing is there's nothing in the Python code in the views.py that knows about the base. What happens is the only place that the base is the only place that the base is noted is in the con2 template itself. It says, hey, go grab this one and extend it. Now the way it works is it starts out a little counterintuitive. It really says start with this template here and then push this content into the base template. And this block content and end block, it basically, that tells what I want to replace. You're replacing blocks in the base template. So all the stuff in the con2.html that is between the block and the end block is what is then pushed into the base template. And then in a sense, the base template with those blocks replaced is what is returned as a result of the render and then returned to Django as the HTTP response. We're going to use these a lot. When we start doing navigation, we're going to go crazy with these things. So up next, we want to talk about URL mapping and reversing, where we have to actually make a link in one page to a different page. So now we're going to take a quick look at URL mapping and URL reversing. This has to do with basically routing, and it really allows us to generate links from one page to another. So we're in the middle of a page and we want to make a link to a different page. We've got to figure out what the string of that is. So again, we're sitting here in the middle of our code. We're in the views, and this URL mapping is basically a set of functions that allow us to read the urls.py. In a way, if all these functions didn't exist that allowed us to read urls.py, we would write a bunch of functions to do that. And so these are just now part of Django. And so often these are used in the view. Sometimes they're actually used right inside urls.py to come up. So it's like, if you know the name of a view, what would be the URL to get to that view? And sometimes views have just a URL, and sometimes they're a URL plus a parameter, and that's all set up here. And so it's like, give me a link to a view, please. And then Django looks in the urls.py, potentially across applications, and gives you that string. And it's just to avoid hard coding the strings. That's really the idea. And so this is just a common problem. This is the documentation right from the Django website. You don't want to hard code these things. You actually can, but then if you rename an application, the whole idea is you could make a Django project that had 4 or 5 applications, and then you could reuse some of those in a different Django project and add some more applications. So, you know, you don't want these applications to have too many hard-coded decisions. And it might be easier to hard-code some of these things, but it is actually in the long run much easier from a maintenance perspective. And so it's better maintenance. It's another, don't repeat yourself, or doing a table lookup rather than hard coding strings. It also lets you hunt around in your code to see where it is that you're talking to that other application. Because we're going to do login eventually, and login is another place. It's not in our application, but our application is going to have to generate login URLs by asking the login application, hey, what's the URL to log in? What's the URL to log out? And that's where we'll mostly start doing this. So I want to talk about it now, so when we get to log in and log out, you'll have that will make more sense to you. And it also is some of the stuff that you're doing from the tutorials. You're putting these reverse lookup things in, and you may or may not know what they are. And my goal here is to give you a little sense of what really they're there for. So let's take a look at an example. So here we have our urls.py, and most of it, I mean, this is the application route, so if you're looking in the samples, it's in the route application. The main thing that we've added is some names. Names are here to look up these paths. We don't really want to look it up by this path mapping because that could actually change. So we're basically saying this view in your views.py, second view, is going to be referenceable by this second dash view. I named them differently very much on purpose. So here's what happens if you just go to the route/route, the name of my application. It pulls up this main/HTML. And so the first thing I want to show you is what a hard-coded URL looks like. Now we know that blah 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 samples/route/second is going to go to that second view because the application's name is route and the view name is second. And that's good. That will work. It's not going to break, but this is where you lose flexibility as you try to recombine applications from one into the other. And so in a sense, what we're asking to do here is we're going to instead use this URL utility. And so in our template, we use curly brace %, and then we're running a utility that's been plugged into the template system that is like when we're running the URL function, as it were, and we're going to pass a string to it, and that is within the route application, the view that is named second view. So that goes into this file, the route urls.py, read down the views until it finds second view, and then it reverse generates the path that works for that. Now in this case, these two strings are going to be the same, and yes, that looks a little uglier, but the key is that we can make changes here, and this will not, the top one, route/second, will not reflect the changes, but if we're looking it up by name, we can do all kinds of crazy things and remap stuff quite naturally. And so again, it's just this URL command, the name of the view, the application, the view. So this is what it looks like when it's all said and done. There's no parameters to this. So if you take a look at this route second view ends up under this hard-coded, the route/second view, the hard-coded ones ends up under the string in the URL output, the page output. We just see it's /route/first is the thing that comes out from running the code URL and passing route:\first view in, so that's what it looks up. And we can make a link. This is now an href, and the actual path is sitting there in the href. So now we're going to see how we do this when we're going from one application to another. So an application we're going to look at in just a bit is this thing called the generic views. It's an application called gview. And we want to make a link to that application, and we know that there are two views. There's a list view and a detail view. And all we have to do is go take a look at the urls.py, and we know that it's an application gview, and this view has a name and that view has a name. The view that is all the cats is got a name of cats, and the view for a single cat is cat. But the cat one takes a parameter. It's an integer number, which is cat number 42 or whatever. And so we're sitting here in the route application, main.html, and we can now go create a URL that actually is pointing to another application and a view within that other application. So this is a URL for gviewcats, and that'll just look it up. So now we don't even have to know what the URL patterns are inside of gview/cats. Now, we can look at gviewcat, which is this URL, but you'll notice that this has a parameter, and so we actually have to add a second parameter, which is that 42 number. And so this will generate the URL straight to the detail page for a single cat. Now, there's a lot of nice stuff about this. So for example, if you omit this, it's going to look this gviewcat up and find it and say, you know what, I'm supposed to have an integer, and it'll blow up on you, right, if you get that wrong. Or if you put a 42 on this one, on the gviewcats, you're not supposed to have a number on that. But gviewcat, you are supposed to have a number. So this is one of the nice things about this reverse URL lookup, in that there's some error checking that goes on, because if it could just blow up silently, and in many ways when code blows up silently, it's worse than blowing up in a spectacular fashion, because if it blows up in a spectacular fashion, you can fix it. So this is what it looks like. So this gviewcats URL and gviewcat42, this one that actually is the detail page that demands a parameter, it constructs that just fine. Okay? So that's going from the route application to the gview application. Now, you can also, this is kind of subtle, and we will need it when we start doing social login using GitHub. So I'll just mention it because we're deep in it right now. And so basically this is actually the overall DJ Free samples urls.py, and that's the one that's pulling all the URLs together kind of in the same folder as settings.py. And so you're pulling in a bunch of URLs, and these live in an application of their own name, but we can actually give them a name of our own to reference them. So you can actually name them, you can reference them with the name they were already given by the application that we're talking to, or we can say, you know what, I'm going to call these social colon or NS route colon. So if we take this route application and include all those URLs, and we're going to use a namespace of NS route, you still can say route colon, or you can also say NS route. And so you can see that in this example, right? We can go to the second view of route, or we can go to the second view of NS. And so there's route. Route is one way in, but NS route is our own way in case we somewhere have an application named route or something like that. And so this allows for a second way to access these URLs using a namespace. And it's not in the urls.py in each application. It is in the urls.py for the Django project. So I just finished showing you all that in the templates, but we can also do this in Python, and we'll find that sometimes in like models.py or views.py, or even sometimes in admin.py, we'll need to sort of be able to find a view in the same or another application and automatically construct it. Sometimes in forms.py, we're going to do it as well. And so this, you tend to call this reverse or reverse lazy to look these things up. And the URL feature inside of the template is pretty much just calling this reverse lazy automatically, because the parameters are kind of the same. So I just want to show you how to do some of those things that I just showed you in templates, how you can do them in Python as well. So here's the one in templates. We just have this little plugin to a template called the URL plugin. It takes one parameter and looks up in the urls.py of the first application, the URL named first view. Maybe there's parameters, in this case there's not, and then it generates a path to that, /route/first, right? And so that's how you do it. It's really under the covers calling this reverse lazy. And so these reverse and reverse lazy are from the Django.urls library. And so in this view, there's nothing tricky about this view. It's just a class-based view. We have a get method. We pass in all the request stuff. But basically, we can call reverse lazy and pass it the exact same string, which is go into the gview application, work your way down until you find the cats, or go into the gview application, go in and find the one for dogs, or in this case, this is the dog detail, and it requires a number, and so this gview dog, go find that one, and then the second parameter is 42, so make me one for that. And in Python, U2, and U3 are all just strings, which I'm passing in through some context under the variables x1, x2, and x3. They're really lousy choices of variable names, but I do that sometimes to point out that they're arbitrary and capricious, and all they have to do is match. And so then, like the x1 matches in this substitution, now we're just doing string substitutions, which is different than calling the URL, but it's still just a bunch of strings. You called reverse lazy in your Python code, and now you're just pulling that string into with double curly braces. And so this is how it ultimately works. We can, we get these, we're just showing how this output turns out, where we go reverse lazy for gview cats, gview dogs, or gview dog with an argument of 42. We pass it in, we replace it, and so this is how it prints out, gview cats /gview dog /gview dog 42. And so that's how that reversing works in Python. And you'll see that certain situations, whether you're like in a model, sometimes you're in a model, it's very common in a model to want to put something about the reverse in it. And the reverse lazy says delay until later to look it up. So up next, we're going to put this all together and ultimately start writing using the generic views, because we're going to look at list pages and detail pages, and in time we're going to look about delete pages and update pages. And Django has these wonderful features that make it work really simply with very little code. Well, we want to talk about it because sometimes the less code you... We're on to our last mini lecture about views, and it's a big one. It's about generic views. It's a really big lecture so that we end up with little tiny views with one line of code. So I've been building up views, and we've talked about inheritance with the templates, and now we're going to talk about inheritance and views. And we've been inheriting all along with views. So here we are in the views.py. This whole thing, these particular kinds of views, we define them in views.py, but they're very informed by the content of model.py. which means that views are constructed automatically just looking at the data in the models.py. So it's again sort of the logic of don't repeat yourself. If you have a thing in models.py, you've defined exactly what the fields are, and things like, you know, what the help text is for this field and what the description for the field is, that has nothing to do with the database, but it can inform the views. And so it's just a way for, you'll see how it all fits together nicely, but sometimes when we use these super awesome techniques, we end up with a little tiny bit of code, and it's really important to deeply understand that tiny bit of code, because you can sort of just fade away and not realize what's going on, because this code is so cleverly reusing a ton of other code and pulling stuff in from other places. So if you go all the way back to, we talked about SQL, the four basic operations are put data in a database, get data out of a database, delete that data, or update that data. CRUD, create, read, update, and delete. And we're going to build a bunch of things, whether they're add things or auto things, where we got to insert an auto, update an auto, delete an auto, list all the autos, insert a cat, delete a cat, list all the cats, update a cat, right? And so we have a bunch of user interfaces that we're going to build over and over and over again. And as you build your own projects, you'll probably have 4 or 5 tables and then little CRUD user interfaces for each of the tables. And sometimes you make them a little different and there's pretty stuff on them and they're customized. But surprisingly often, these things just look the same and we end up repeating ourselves, which is something we don't want to do as software developers. So here is a simple CRUD application. It's the cur, create and read. Or no, actually, it's this one here is only read and detail. So we have a list of cats, and then you click on the cat list, and then you see the data for a particular cat, and then a link back to the list. So this is like a detail page. But we're going to do a lot more than that. But this, I just want to show you how these generic views work by keeping things very, very simple. So we're going to talk about a generic view in the list and the detail, which are 2 of several generic views. So this is our GView application, and here's the urls.py. In this GView, it has a list of cats, an individual cat, a list of dogs, an individual dog. And so you see this sort of repetition. And I'm putting so many of these in here because I'm going to show you sort of different approaches to implement them using less and more detail and less and more inheritance. So they're all kind of the same. I give them a name. You know, some have integer primary keys, and away you go. And so here is the cat list. I'm going to start with a template. So we're going to expect in the cat list template that there is a context variable called cat_list, and that is a list of cat objects. And then we are going to iterate through the cat list, however many cats there are, with inside of a list, and generate an li tag, and then create a link URL, and then pull out the name of the cat. So the cat has a name, and the cat has a primary key, and so we are going to generate a link to the cat Sophie, and underneath that link is the link to /cat/12, whatever that number is. And if the cat list is empty, we're going to say there are no cats in the database. Now we've actually got a script that you use to preload all of this data. So there's instructions in the sample code as to how to preload that data. Take a look at the README for it. And so if we're in the detail page, we're going to pass a cat object in, and that has a name, and then we want a link to go back to the cat list. And so again, we're using something from the immediately previous lecture where we're using the URL macro, passing in the name of a view within an application. So this is the GView applications, the cat view, and then that makes for an href, that makes a valid link with the string go back to list to be the thing that does. So we're going to build all this stuff, and that's the basic idea, that template and the HTML, that's how we're going to do it. But we're going to look at how the views work. And again, this is a reminder of the dry principle, the don't repeat yourself principle. Again, sometimes this dry principle gets us in trouble because the idea is that some bit of logic is placed one place and reused as many places as possible, because don't repeat yourself would probably be as well described by calling reuse, 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 reuse. Do it once and then reuse it as many times as possible, so that if you have to fix it and you got a bug in it, you don't have to find the 49 places that you put all this code. And because we do the same thing over and over and over again, cats, dogs, horses, we do it over and over and over again, cars. The idea that you have a list view, a detail view, an edit view, etc., it's a common thing. And really, if you're going to do this stuff, why not make it look consistent and function consistently? If you have one developer build the cat's editing interface and another person develop the dog's editing interface, and they like go off the same, go off in their own way, and they got some groovy design, but it's different, who cares, right? It's inconsistent. So consistent, you still want a beautiful design, but you want the cat's data and the dog's data to make sense with that consistent design. So both of them can have a nice design. So we got templates. The templates expect variables, like the list expects a thing called cat underscore list or dog underscore list or whatever, and then the cat detail just has a cat variable in it, and then we call it. So if we just forgot about all the stuff that we're about to learn and we just wrote a view, it would look like this first one, this cat list view here. And so we would inherit from view. We're going to go to the database. We've imported the cat model, cat.objects. This is the way to query all the cat objects and get a list of cat objects and put it in the variable stuff. That's what cat.objects.all does. Now we've done this before like in the shell, but now we're doing it in actual Python code in the views. Like I said, views are where all the stuff happens. So that says make a database call, load all the cat records, turn them into objects, and give me a list of those objects. And then I'm going to pass in the context into the template, the gview/catlist.html, I'm going to pass an entire list. And if you go back and look, there was a little loop in the template that printed out, Sophie, Frankie, and made links underneath them into the detail page. Okay? So this is how we would do it if we were going to not repeat ourselves. Okay? Now, this next way of doing it for the dogs, we're going to do it another way. And so what we're going to do is, it looks like it's more work, but it's more reusable. So the stuff that we're doing here. So what we're doing is, now we have a dog list view, which is just a class, and we're going to create an attribute variable in this object called model. And we're just going to say that this model for this particular one is dog. So the idea now is, in this get method, we take this code right here, and we said cat, make that be generic and have it be driven by this one variable. Okay? Now the tricky part that makes this a little tricky is sometimes we're just using the model, and then other times we are going to actually turn it into a text string. So if we take a look at this, boop, boop, we have this variable model, and in the get request, self.model is the way refer to the particular instance that we're in, that model variable. And this little meta verbose underscore name title to lowercase. You can figure that out by yourself by going to Stack Overflow eventually. That's how I figured it out. I wanted to get a lowercase version of the model name. So the model's name is a string DOG, which is not the same as the dog model. Okay? And so that just is a way, model name is going to be lowercase dog. But if model is cat, then model name will be lowercase cat in this bit. So I'm trying to make reusable code. So yes, the reusable code looks a little more complex because it's generic. But you'll notice that I'm creating a variable called model name underscore list because I'm just concatenating it together. So it's model name and is going to be dog underscore list. So that's what's going to happen. I am going to talk to the model and retrieve all the objects. That's okay. I don't have to change it to a string. Self.model is dog.objects.all. So then I'm going to get a list of all the objects and stuff, and I'll put that in the context. And then I'm going to go get myself a template out of the gview folder. with the model name underscore list, so that what used to be cat list in here is now dog underscore list. I'm concatenating it together, and I passed the context in. And so then when that happens, then you get a dog list and some list of dogs, and away you go. So what I did is I generalized this code and put it in here, and then I passed in a sense, to the object that was made from the dog list view class, the actual model that I wanted it to operate on. Okay? So I do this to give you a sense of how this works. You can do the exact same thing for horses by doing this. And that is, you import the generic, Django views generic, right here, and you say, I'm going to make a class called horse list views. I'm going to extend not just view, but generic list view. So this is a generic class. You can go look at the Django documentation for this. It's a generic class that does a list view in general. And the rule for the class is you have to add one line here to say which model it functions on. And that's it. And that's because the get code is already in this model. We're extending that model. We're inheriting all this code, not from dog list view, but instead from generic list view. So we took something that was 5 lines, a little more generalized, it's like 8 lines, and now it's 1 line. And so that's how the extension works. But you have to trust, and you have to go read the documentation for list view to know how it is that you inform it as to what model you're supposed to use. So I want to show you a little bit of how this is happening by making one of these list views that's mine. It's not as cool as the real Django list view, just to give you a sense of what's going on behind the scenes in the Django list view. So if you say, so I'm going to make a new class, DJ4E list view, and then I'm going to extend view, and then I'm going to have a get method, and it's going to be all this code. It's looking for a variable called model, and you'll notice that it's not defining model up here because it's intended that this is a class that's going to be reused. So I'm going to say, oh, well, whatever the model is that's been set up here by the class that's being created while we're extending it, go grab that, convert it to a text, get the title of it, and then convert it to lowercase, make that model name. Whatever the model is, retrieve all of its objects and put it into stuff, and then put model name underscore list, in this case car underscore list, and then pass that list into the template, and then render, gview car underscore list context. Okay, so this is not doing anything per se. DJ4E list view is creating a class that I'm going to extend later, and I'm going to extend that 2 lines later. I'm making a car list view that extends DJ4E list view, and the only thing I need to do to get all of this code in here is extend it, and then I do need to add model equals car. So you'll notice that car list view has the exact same syntax as horse list view, right? Horse list view, you basically tell it, the generic list view, tell what model to work on, and then generic list view does it all. And if you look at car list view, it says use this generic list view that I just invented to show you the source code of what it is. That's the source code behind the scenes. Like I said, it's way more complex and sophisticated than what I did. This is the crudest, simplest version of an extendable generic list view. But when it's all said and done, you don't write any of those versions. You literally make a list view and tell it what model it is. You make a cat view and tell it what model it is. And you just reuse the list view over and over and over again. So the fact that I give you 4 different ways to do this, yeah, I think 4 different ways, maybe 5, 4 or 5 different ways to doing this. The real way to do it is one way, but when you look at code like that, you're like, horse list view is an extending generic list view and the model is horse. I'm trusting a lot. And the answer is, yeah, you get used to it. And now the code you have to write is only 2 lines of code. And you have to write the template still because it's going to call your templates, but it knows the name of the template by looking at that horse, right? It knows, oh, horse, oh yeah, horse underscore detail, right? Or horse underscore list. And so this is the actual detail page that shows you the horse and goes back to the list, etc., etc., etc. And so using these generic views, you can make things really short and really succinct and really simple. So Generic views are excellent. They allow us to produce lots of similar pages without repeating ourselves. They keep your code consistent. The repeating yourself, doing the same thing over and over, even if it seems quick to cut, paste, change, cut, paste, change, cut, paste, change,